I want to teach on the general gas law or general gas equation. That's the general gas equation. The general gas equation still on the gas law. Now, the general gas equation, I told you about the Boyle's law. The Boyle's law tells us a relationship between what? Telling a relationship between volume and pressure. You understand? Telling us that volume and pressure are inversely proportional to each other, and when this one goes up, this one also goes up. Now, that's for Boyle's law. Then Charles' law is telling us that volume for the Charles law now, but this one is at when the temperature is constant. The volume is inversely proportional to the pressure when the temperature is constant. But for Charles law, that the pressure is constant, that the volume is directly proportional to the temperature. You understand? So when the volume is directly proportional to the temperature, so we have what V1 over T1 equals what V2 over T2. This is Charles law, and that's the Boyle's law. So combining both laws now, combining this, so we have what? P1 over V1 equals what? T1 equals what? P2, V2 equals what? T2. This is the general gas equation. Because by the time I combine this one, if this is constant and we have what? P and T. That's so we'll be having PV over T. That is if I should combine. So the general gas equation is telling us that is a combination of the Boyle's and the Charles law. So for me to have all the three variables in one, then that's the general gas equation. So we have the pressure, we have the volume, and we have the temperature. You understand? Then mind you, don't forget that the pressure always in what? Millimeter mercury, atm, pascal, or kilopascal. That's pressure. Then temperature usually in degrees Celsius converted to what? To Kelvin. And then the volume usually in cm cube, dm cube, or in liter. So these are the things you have to consider if you are to look at the general gas equation. The general gas equation is very, very simple because it's a combination of both laws. Just look at it. I'm going to use an example. So that we can solve. I'm going to give you two examples on the general gas equation because there are different questions. For the first example is going to talk about the normal general gas equation. Then the other one at STP. So here we are going to be introducing a standard temperature and pressure, which we are going to discuss later. Let me give us an example on the general gas equation so you see what I'm talking about. So let me clean this. Then I'll write questions on the board. So you now see. So let's like 200 cm cube of hydrogen. Okay, let me write it. 200 of hydrogen gas was compressed at 5 degrees Celsius. At 5 degrees Celsius in 760 mShg of pressure. Then what will be the volume? What will be the volume if the temperature was raised to 10 degrees and the pressure to 900 mmHg? So this type of question is a standard general gas equation because we have almost everything. Looking at this one, we have pressure, we have volume, we have pressure, and we have what? Temperature. So this is one of the best way you can know that okay, this is general gas equation. And like I said, the other question will be the one at general gas equation involving STP. So we are going to explain that, but let's look at this one. Now let's start writing out what we need in this question. The parameters we have V1 equals to 200 cm cube. How did I get my V1? This is the first volume that was mentioned in the question. Then I have the T1 there. T1 which equals what? 5 degrees Celsius plus 273. That's 278. When I converted from what? Degrees to what? To Kelvin. I said it is very important for you to convert from degrees Celsius to Kelvin because that is the standard. That's the standard measurement for temperature. Then I have P1 equals what? 760 mmHg. Then they ask us what is the volume? That's the question mark. What's volume? Question mark. Because that's what we're looking for. What will be the volume from here? If the temperature was raised to 10, so we have T2 equals to 10 degrees Celsius plus 273, which is equals to what? 2. That's I have 283 K plus 10. Then what about the second pressure? The other pressure, the last pressure there is what? 900 mmHg. Having this, you already have, you can see I have V1, I have T1, and I have P1. Then I have what? T1, I have T2, and I have P2. So what is missing here is what? Is the volume. So and that's what we are going to do. So we now go back to our general gas equation, which says that P1 V1 over T1 equals to what? P2 V2 over what? T2. So this is the equation. So how do we spread it out? Let's spread all what we have here. So we have what? So we have 760 times volume 1 times 200 over T1. That's 278. 278 equals to what? Then P2 from the question. Our P2, that's the second pressure, that's 900 times what are our T2 here? Our T2 is at 283. That's we are looking at P1, so times what? V2, the volume over the T2, and our T2 here is what? That's 283. 283. So we have P1, we have V1, then we have T1, then we have P2, then we have V2, then we have what? T2. So what do we do? Okay, so this is, so we have, after cross multiplying, we have what? We have 760 times 200 and 283 over this. So I like just straightforward, so we have the answer there. So we have 43,01600 divided by 250, and after dividing this over this, we have 171.9 cm3 being the V2 as the volume. So that is the general gas equation. That's how to solve that. Now the general gas equation have another part, and the other part is you having to solve. The other part is you having to solve at STP. Yes, and you having to solve at STP. Now, what is the essence of the STP, or what is involved in STP? STP involves that you have been given a standard temperature. That's a standard temperature, which is what was 0 degrees Celsius, equals what? 273 K. So at STP is what? There is standard temperature there, and also what? A standard, that's a standard pressure, and that's what? 760 mmHg, or 1 atmosphere. You understand? So, or 1 kPa, or that's Pascal 1. So this is standard temperature and standard pressure. So in a situation whereby you see that you have a question at STP is just straightforward. It means that automatically two things have been given to us at STP. That's the standard temperature and the standard pressure. It's as simple as that. So let me give you a question that involves you calculating at STP. So it's going to be very straightforward. So let's say 300 cm3 of a gas was used up and exposed, at STP. Then what is the volume or new volume if the temperature was raised, either raised or decreased to maybe like 3 degrees Celsius, and pressure to 7, okay, let's say pressure to 800 mmHg. So that is that. Now, when you see a question like this, what is the volume? We are looking for the volume. Then the first volume has been given to us. This is the second volume. Let me write down the parameters. This is the first volume. V1 here equals to what? 300 cm3. You understand? Straightforward. That's the first volume. Then what about this issue of STP? STP means that there's a standard temperature which is what 273 K or 1 degree Celsius. There's a standard pressure there too, which is what 760 mmHg. You can see that out of the 6, we have 3 straight. Then the next one is what? V2. What is V2? V2 is what we are looking for. Then what about the temperature? The temperature was raised, so we have T2 equals to what? 273 plus 3, that's 276 K. That's the temperature. Then what about the pressure? Then the pressure, which is also P equals to what? 800 mmHg. So you can see. So now let us now apply the formula. That's P1 V1 over T1 equals what? P2 V2 over T2. So here we have P1 here. P1 equals what? 760 times, what's our first volume? Our first volume here is 300 over what's our T1? T1 is what? 273, which is equals to what? P2. P2 is what? 800 times what? V2 over what's our T2 here? Our T2 here is what? 276. So this is doing this alone, then you already interpret the question. So what do you have? We have what? We now have 760 times 300 times 276 equals to what? 800 times 273 times what? V2. So my V2 here equals to what? 760 times 300 times 276 over 800 times 273. How did I do that? What happened is that just divide both sides by this. If I divide both sides by this, then I have my V2. So this is what I have. So let us calculate this and let's see what we get. What did we get? Anything we get here in CMQ. So this is the question as well at STP. Mind you, I've explained the one at STP. So let us calculate this and cross multiplying. We have 760 times 300 times this over 800 times 273. So we have 62928,000 over 218,400. So our answer is 288 cm3. That's our V2. So that is that about the STP. And sometimes it also depends on you have to be careful on how the STP is being placed. Sometimes at the first STP might be just like the way jamb usually said your question. If the STP is coming for the first statement, then you know that okay, that's T1 and T2. But sometimes it can be compressed, it can be decreased. You understand? So, and we can have the STP after giving off the V1, the T1, and the P1. Then the now said at STP, what is the V2 or what's temperature? So you know that the STP, then it was not a standard measurement of temperature and pressure, but now it's a standard measurement. So that's why the STP is coming as later. So that is how you solve the general gas equation. So don't forget, I'm going to drop some other questions, a lot of questions, probably 3 or 4 questions in the comment section. So solve it, try it on your own, and you understand it. The only thing you just need on this is a formula: V1 over T1 equals what? P2 V2 over T2 over T2. This is all you need. So just look at it. Take a look at the question very well. Identify your P1, your volume 1, your T1, P2, and that's all you need. So that is all about that. You see now in this video. Good day.